In this session we're going to talk about modulus functions. Okay, now what is a modulus function? A modulus function, it is also known as an absolute value function. Now this is just a mathematical function that returns the magnitude or the size or the absolute value of a given number regardless of its sign. Let's say because it is defined by, if you say the modulus of x will be defined where it will be equals to x if and only if your x in this case is greater than or equal to 0. You must understand that. Then the modulus of x can also be equals to negative x, but now the condition in this case, it will be if your x is less than 0, right? Okay, so these are the conditions that you need to understand for a modulus function. Okay, now let's proceed. If we are told, if they ask you to, let's say they've asked you to evaluate, the absolute value of the following. Let's say they've asked you to find the absolute value of 5. So in this case, it will just be a 5, because we're saying whether there's a 5. Then let's say they've asked you to find the absolute value of negative 3. So the answer will just be a 3, like that. Okay. Let's say they've also asked you to find, the value of the negative 4. It will just be 4. So now what this means is you square the number, or you square that number, then you square root the answer. Let's say if I square 4, that will just be 16. Then this 16, I have to find the square root of 16 again, which will just give me a 4, like that. That's what we're talking about. Okay, so yes, so even if you get a negative number, if I say negative 4 squared, it will just still give me 16, and I'll still square that. Okay, let's say you're also asked to find the modulus of 0. The modulus of 0 will just be equals to 0. Okay, then let's say you're asked to find the modulus of let's say negative 3 minus 4. This is in bars. Okay, what are you going to have? In this case, you are going to have the modulus of negative 3 minus 4, that is just negative 7. Okay, we're finding the modulus of that. Then the modulus of negative 7 is just a 7. So you are done with that. Let's say you're also asked to find the modulus of negative 3, let's say minus, then there's a modulus, then you say negative 4, then there's a modulus, then now there's the actual modulus, the big modulus, like that. So how are you going to solve this one? Okay, so your negative 3 will just be there, and your minus, now the modulus of negative 4 is just 4. Okay, so you have 4, like that. Now negative 3 minus 4, that is just a negative 7. Okay, then the modulus of negative 7 is just 7. Let's also try another one. What if you have the modulus, you're asking you to find the modulus of 2 minus, let's say modulus of 4 minus 3, modulus minus 3, modulus 2 minus 7. Okay, there's a bar again, and the actual big bar, like that. Okay, so now how are we going to solve this one? Okay, so let's solve where we can easily solve. So your 2 remain minus the modulus of 4 minus 3. Okay, 4 minus 3, that is just a 1. Then the modulus of 1 is just 1. So here it's 1. Okay, then we have a minus 3. We write it. Then the modulus of 2 minus 7. 2 minus 7 is 5. Okay, so in this case we have a 5 here. Okay, then you have the big modulus like that. Okay, so now what are we going to have when you do that? So you're going to have a scenario where you have 2 minus, okay, minus 1, then your 3 multiplied by your 5, that is just 15, but now there's a negative, so it will be negative 15. Then you're finding the modulus of this. Okay, then you're trying to find the modulus of 2 minus 1, that is just 1. 1 minus 15, that is negative 14. Okay, so now you're trying to find the modulus of negative 14, which is just 14 like that. Okay, so this is how you're going to solve that one. Then how do you solve modulus equations? Let's say they've given you there's this expression that you're supposed to know, the modulus of x, then they tell you to find a. Now how are you going to find the value of x? You are going to say x it will be positive or minus a. Okay, in this case, when you remove the modulus, your answer on the other side will be either positive or a negative. Okay, let's say you are given an expression. Let's say our equation in this case 0 is equals to, let's say, negative 2 plus 3, you know, the modulus of x plus 1. So now what are we going to do in this case? Okay, we're going to solve. So we're going to take this negative 2 to the other side. So you have 2 is equals to 3, the modulus of x plus 1, then like that. Okay, so for it to remain with the modulus on the other side, so you're going to divide by 3 on both sides. So you have 2 over 3 is equals to x plus 1. This is in the modulus. Okay, so now what are you going to do? When you are removing the modulus, like we said, on the other side is just positive or minus. So it will be x, when you remove the modulus, x plus 1 is equals to positive or minus 2 over 3. Okay, in this case your x is just equals to 1, or let me say positive 2 over 3 minus 1, or x will be equals to negative 2 over 3 plus, no, minus 1 actually as well. So these will be your answers like that. Okay, now let's sketch some modulus functions. How do you sketch modulus functions? Let's say the first scenario that we can give is f of x is equals to the modulus of x. Okay, now how are we going to solve this one? Okay, since this is just the introduction, let's solve this one. Let's have a table of values. Now allow me to use 3 coordinates. Let's say we've got x and we've got y. This is our table of values. Okay, let's say this is our table of values. Okay, okay, just like that. Now what are we now going to have? So like I said, allow me to pick, let me just use 3 coordinates, a positive, because 3 will just be enough. I'll get a positive value, a 0, and a negative value like that. Okay, so let me say x. Now if we replace, let's start with maybe 1. If we put 1 in this function, the modulus of 1 will just be equals to 1, right? Okay, so it means the function just give me a 1 there. Let's say, what if I put a 0? The modulus of 0 will just be equals to 0. Okay, so this will just be 0. Then let me say a negative number, like let me say negative 1. The modulus of negative 1 will just be 1. Okay, so those will be my coordinates like that. Then if I'm to graph these ones, how am I going to have my graph? How is my graph going to be? Let me say this is our graph. Okay, so let's say this is your y, this is your x-axis. Now if let's say this is 1, our first point is 1 comma 1, so let's say 1 is also there. This is our point. Then our next point is 0 comma 0, which is just there. Then we also have negative 1. Let's say negative 1 is here, comma 1, which is just there. Okay, now since this is an absolute function, so what are you going to have? So if we are going to draw this one, so you see that our graph in this case goes in this direction, passing through that point, and it also goes through this direction, passing through that point. Okay, so this will be the our expression, and this will be our graph. Now you realize that our graph in this case, it didn't pass going this side, but it has been reflected to go this direction. Okay, so the reason for that is because even the modulus of a negative number in this case will just give us a positive value. So the line was just supposed to contain only downward, supposed to continue downwards, but we can't. Why? Because we just want positive values, hence it is reflected up like that. Okay, now let's say what if you don't want now to use this table method. So the quicker way that you just do is you get the expression that is in the expression you get this the expression that is in the modulus, you equate it to 0. So you have x will be equals to 0. Okay, x will be equals to 0. This will be the line of symmetry, or this will be the point where to cut the the graph into two equal parts. Okay, so the x is equals to 0. In this case, it will just be at the same point. Let me show with a different color. It will just be at this point. Okay, and it will be reflected like that. What you just do, it goes in the other side, and it also goes in the other side. Okay, so the function is going to be in the y values which are only positive. Okay, so that's what you're supposed to know. Let's say now the same scenario, but now in this scenario, let's say instead of a positive like that, what if we put a negative here? So in this case, our graph will just be reflected so it will be something like that. I'll not draw it to scale. We're going to equate what is there to be equals to 0, so x is just be equals to 0. So you know that your graph the line of symmetry is just being cut at x, so it will be reflected because we only want the values of y. The function is going to be going to the y values which are negative. Okay, so it will go in this direction and it will go in that other direction. Okay, not really drawn to scale, so it will go in this direction and in that direction. So that will be our function. Okay, let's solve another one. Let's say you're asked to find the f of x. Your f of x, in this case, we're saying you're trying to find x. Let's put a number in the modulus, x minus 2. Okay, like we earlier said, if you don't want to use the table of values, you're just going to equate x minus 2 is equals to 0. So x is equals to 2, like that. So this is where your graph for the function, it means that x is going to start at 2. So what are we going to do? So let's just draw our graph. Okay, so let me draw it here. Okay, so if that is 2, so it will go this side if that is 2, and the other side like that. Okay, so in this case, let's say this is our 2. That would be our line of symmetry. That's where you can cut this into 2 equal parts like that. Okay, so that's what we're just talking about. So now that we found our line of symmetry, you've seen that it is going to cut the y-axis here. So you have to find that a point. Okay, so to find that the y-intercept, what are you going to have? Since the function cuts the y-axis, you need to find that value. So you know that on the y-axis x is equals to 0, right? Okay, the y-axis, this y, this is x. On this equation, just the same as x is equals to 0. This is just the same as y is equals to 0. Okay, so what are you going to have? You're going to write your actual function, but wherever there is x, you're going to be putting 0 is equals to 0 minus 2. Okay, so f of 0 in this case will just be equals to the absolute value of 0 minus 2, that is just minus 2. The absolute value of 2 or negative 2 would just be a 2 like that. Okay, so it means this point here will just be a 2 like that. Okay, so that's how it's going to be. Then let's say you put a negative number here. Now if you put a negative number there, what are we going to have? It just means that your graph will be reflected downward. Okay, your graph will be reflected downwards, going like that. Okay, the same one, but just be reflected downwards like that, and you'll be supposed again to find this point, and when you do the equation, it will just give you a negative number like that. Okay, now let's solve another one. Let's say you're asked to find f of x is equals to minus 2x plus 3. Okay, so now what are you going to have? Like we said, you equate what is in the modulus to be equals to 0. So you have 2x plus 3 is equals to 0. So 2x is equals to negative 3 when it goes on the other side. When you divide by 2 on both sides, you're going to have negative 3 over 2. So this is where the graph is starting. Okay, now we have a negative, so you have to be mindful. So in this case, your graph will be going to what? It will be reflected downwards. Okay, so let's just draw. Okay, let's say our graph is this one. Let's say this is the y-axis, this is the x-axis. Okay, now let's put let's say our negative 3 over 2, let's say it's here. Okay, that is the point. Now if this is the point, what are we now going to have? In this case, where our graph, so it will go, because there's a negative here, what are we going to have? It will go in this direction, and it will go in that direction like that. Okay, now we are seeing that it's cutting the y-axis there. So we're supposed to find where it cuts the y-axis there. Okay, so again, we're going just to equate the equation to be equals to, we're going to put wherever there is x, we'll be putting 0. So f of 0 is just be equals to negative the modulus of 2, x is 0 plus 3 the modulus. Okay, this will just give us negative 2 multiplied by 0, that is just 0 plus 3, so 3. Then the modulus of 3 it will just be 3. So it means our f of 0 in this case, where it's cutting the y-axis, it will just be at negative 3 like that. Okay, at negative 3 like that. So that's how you find that one. Now let's see the effect of a constant outside an absolute function. Let's say you have a scenario where you have f of x. Let's say the modulus of x plus 4. Okay, so like like the way we've been doing, you equate what is in the equation, or what is in the modulus to be equals to 0. So in this case, your x is just equals to 0. Okay, so when we draw, what are we going to have when we draw? Okay, let's say this is our y-axis, this is our x-axis. Okay, so we're saying x is equals to 0. So now where is it going to start on the y? Because now we see that this is just a positive, right? So it's going to be going up. So what are we now going to do? Let's find where it's where the y axis is, or where it's going to start from on the y axis. So again, we're going to equate wherever there is x, we'll be putting 0, because x is equals to 0. So f of 0 is just equals to the modulus of x. We're saying is 0, so the modulus of 0 plus 4. So the modulus of 0 is just 0 plus 4. 0 plus 4 is just a 4. So starting at 4, this is where our graph is starting. Now because the coefficient of the modulus is a positive, so it's going to be going up like that. So it will go up like that. It will be going up like that. Okay, so that's how it will be. It will be going. So that will be your answer like that. Okay, and we are saying this is it's starting at 4. You also indicate this is 4. Okay, the point here is 4. Okay, let's have another scenario. Let's say you are trying to find f of x is equals to, let's say, negative the modulus, okay, of x plus 3. Okay, now we've put a negative and a constant. So what are you going to do? Again, you're going to equate what is there to be equals to 0. So x is just equals to 0. So you're going to draw your graph. Okay, you draw your graph like that and like that. So now what are you going to now have? Okay, so now let's find where we're going to start from in terms of the y-axis. So the y-axis, again, we said we are going to equate everything to wherever there's x, we'll be putting 0. So f of 0 will be equals to negative 1. This is negative 1. Actually it's negative. Then the modulus of 0 plus 3. So f of 0 in this case will just be equals to, the modulus of 0 is 0. Okay, so you just have a 3. So it is starting at a 3, but now in which direction? You have to look at the coefficient of the modulus. In this case, it's a negative 1. So because it's a negative, it's going to be going down. So let's just do that. Okay, let's just do that. So it's going to go this way, and it's going to go that way. Okay. Okay. Now we are. You realize that it's cutting the graph on this part and on this part. So we have to find now the x-intercepts. Okay, so now how are you going to find the x-intercepts? You are going to again equate the whole function to be equals to 0. Now wherever there's y, where there's y, you're going to put 0. Your y in this case is just f of x, right? So it will be 0. It will be equals to negative the modulus of x plus 3. Then you solve. So you take your 3 on the other side. or let me just say, let me take the modulus itself to the other side, because it's a negative modulus, so it will be positive x modulus, or the modulus of x like that is equals to 3 will remain on that side. Then what did we say when you want to remove the modulus? Okay, so it will be x. For it to find x, just be positive or minus 3. So this point, this is positive 3, this is negative 3 there. So these are the points like that. Okay, so that's how you solve this one, and you might have shown like that. So that's how you draw that one. Now let's solve another one. Let's say you have f of x. Your f of x is equals to negative. Let's say you have a constant in the modulus x minus 4. Then you also have a negative. Now you have a negative 3 there, a negative constant. So what are you going to have? You are going to equate what is in the modulus to be equals to 0. So x minus 4 is equals to 0. So x is equals to 4, right? Okay. Now the constant that has been added to the functions changes where the y value will be, because that's where the y value will be. So what are we going to have? So our graph, if we're going to draw our graph, let's say this is our graph. Okay, let's say this is our graph. Okay, so now we are saying x is equals to 4. Let's say 4 is here. Okay, 4 is here. Then we have we're saying that the constant that we've put here, this will be where our y coordinate will be. Okay, so in this case this is just negative 3, so negative 3 is here. So let's put here, this is where our graph is going to start from. Now in which direction? We have to look again at the coefficient of the modulus. Now the coefficient of the modulus in this case is a negative 1. Okay, a negative 1. So it means the graph is going downwards. Okay, the graph is going downwards. Okay, so what are we going to do? Okay, so let's do that. So we're saying, okay, let me just increase this one to be going down like that. So it means this, because it's going downwards, it will go in this direction, it will also go in that direction. Okay, it will go in that direction. So let's say now that it has cut the y-axis there, so we have to find the value of y at that point, at this point. So let's find the value of y at that point. So how do you find the value of y at that point? On the y-axis, x is equals to 0. So you're going to say f of wherever there's x, will be putting 0. So it will be equals to negative 1, the modulus of 0 minus 4, then there's a minus 3 outside. Okay, f of 0 in this case will just be equals to negative 1, 0 minus 4, that is negative 4. The modulus of negative 4, that is just a 4. Okay, so this is just a 4. Okay, minus 3, so we're going to get negative 7. So in this case it is cutting the y-axis on negative 7 like that. So this is how we show for this kind of a modulus function. Now let's solve the last one. Let's make it complex a bit. Let's say you have f of x is equals to let's say negative 2 plus 3, okay, x plus 1. Okay, so now how are we going to solve this one? Okay, so you have to get what is in the modulus, you equate it to 0, so x plus 1 is equals to 0, so x is equals to negative 1. Okay, now this number that we've put in front of the modulus, it doesn't change anything, but what it just does is that it's going to either widen the function or lessen it. What I mean is, you know, it can either be like that, because it's a positive number, so it can either maybe even widen it like that. So it's just the size that will be different. Okay, that just shows the magnitude of that modulus function. Okay, so let's now do that. So what are we now going to have? Let's find the y and the x intercepts. So on the y-intercepts, x is equals to 0, right? So let's just find them in advance. So we have got f of 0 will be equals to negative 2 plus 3. We say on the y-axis x is equals to 0, so where there's x, we put 0 plus 1, the modulus, like that. So we're going to have negative 2, positive 3. Now 0 plus 1, that is just 1. The modulus of 1 is just 1. Okay, 1 multiplied by 3 is just 3. So negative 2 plus 3, that is just a 1, like that. Okay, so this is where it's going to, like, where to be cutting the y-axis, because on the y-intercept x is equals to 0, so this will be our y-intercept. Okay, now let's find our x intercepts, if it's going to have x intercepts. So on the x intercepts, y is equals to 0, right? So y in this case is just your f of x, right? So f of x will be equals to 0. So 0 is equals to negative 2 plus 3, the modulus of x, plus 1 modulus. Okay, so what are you going to have? Like our initial, so we're going to take the negative 2 on the other side, so it will be 2 is equals to 3, the modulus of x plus 1, like that. Okay, then for it to remain with your modulus, you're going to divide by 3 on both sides. Okay, so you have a scenario where you have x plus 1 this is in modulus, so it is 2 over 3. Then to remain with what you have in the bracket, what are you going to now solve? So to remove the brackets, you have x plus 1, it will be equals to positive or minus 2 over 3. Then for it to remain with your x, so your x in this case will just be x will be equals to 2 over 3, your negative 1, this is a positive 1, or x will be negative 2 over 3 minus 1. Okay, and when you solve these ones, when you solve 2 over 3 over negative 1, this will just give you 2 over 3 minus 1, and that will just give us, let's see, just give us negative 1 over 3. Then this other one, negative 2 over 3 minus 1, this will just give us, let's say, negative 5 over 3. So these will be our x intercepts. Now let's graph these ones. Let's now graph the thing, the function, the modulus function. Okay, okay, so this is our y-intercept. Okay, so find that our y-intercept is just equals to 1. So now let's okay, so let's graph it. How are we going to do it? Let's say this is our y-axis, this is our x-axis. Okay, let's just extend it a bit this side. Okay, like that. Okay, okay, something like that. Then what are we now going to do? We found points like we had a negative 2. Let's put first our let's say, what if this is negative, let's say this is negative 3 over 5, then negative 1 over 3 there. Then we said it cuts the y-axis. Let's say this is our 1. Okay, that is our 1 there. So these are our points. Okay, these are our points. Now where is our graph starting? Okay, our graph, we said starting at x is equals to, when we equate what is in the brackets, x is equals to negative 1, like that. Now it's equals to negative 1, so it means, let's say we have negative 1 comma negative 2, which would be somewhere here. Okay, now we have a positive number here, so it means your graph, in this case, there'll be straight lines. So in this case your graph will just be from here, it goes there, and from there it passes through these points, it goes like that. Okay, because it's a positive, so it just reflects like upwards, like that. Then we say this point we said, because we said you have to equate what is in the brackets, x plus 1 should be equals to 0, so x in this case is equals to negative 1. So our x in this case was negative 1, which is here, and how does it reflect? It goes upwards, like that. Okay, so that's how you solve these modulus functions. I'll see you in the next session. Thank you.